In this video, we are going to do two questions from trigonometric identities, class 10th. So let's begin with the first question here. Now in the first question, as you can see, this is what our LHS, and we have to prove this is equal to this as well as this. Now, what you can observe here that we have the numerator of this is equal to the denominator of the second and same as for the other. So here we are going to take LCM. So I'll take LCM here. LCM is going to be what? This is sine minus cos theta, that multiplied by sine plus cos theta, sine theta plus cos theta. Now let's say if I do so, I'll be multiplying this with sine plus cos. So we'll get what? This is sine plus cos, sine theta plus cos theta whole square, and so on for the other part, that is sine theta minus cos theta whole square. Now, after that, I'm going to use the expansion using a plus b whole square or a minus b whole square. Let's see if I do for the first part, this is a plus b whole square. That's what this is, a square plus b square plus 2 into a into b. And for the other part, let's say talking about this, what is this? This is again a square. This is a minus b whole square, right? A square plus b square minus 2 times a into b, that is 2 times sine theta into cos theta. And that whole divided by, you can see over here the denominator is in the form of a minus b into a plus b, which is a square minus b square. So it's sine square theta minus cos square theta. Now check here. Here we are finding that 2 sine theta cos theta positive and 2 sine theta cos theta negative. So you can figure out from here that this is sine square plus cos square theta, which is 1. Well, this will turn as 1, and this also, which is sine square plus cos square, which is 1. So this is 1 here and 1. So 1 plus 1, that is 2, right? This is 2 over, that's the numerator left here, that divided by sine square theta minus cos square theta. Now we can figure out that we got one part of the two proof, and then we have to write this in form of this, that is 2 sine square minus 1. Well, we need sine square, not cos square, so we are going to convert this cos square. I can replace this cos square. What we know, cos square can be written as 1 minus sine square theta, right? We know that cos square theta is 1 minus sine square theta. So this is what I'm going to do in the next part. So this is 2 over, let sine square be sine square only, minus, I'm going to replace this. That's an important thing to consider, that there's a minus sign. So whatever I'm replacing cos square with should be inside a bracket, that is 1 minus sine square theta. Now check here, if I open this bracket here, is going to be 2 times. If I open this bracket, this is sine square theta. If I open this is minus, and as you know that this bracket will open to make it positive sine square theta. So we'll finally get 2 divided by sine square plus sine square is 2 times sine square theta and minus 1. And I can see that we got this second part as well, right? So we can say that the proof for the first part going to be this, and for the other parts going to be this. Now let's move to the next question. In the second question, you can see that we have this as the LHS, and we have to simplify it to get 2. Well, for solving this, we are going to apply these two identities, that algebraic identities, not trigonometry one. So here, in the first part, I'm going to apply this identity of AQ plus BQ. So let's begin with applying A is what? Cos. So we can say this is cos theta plus sine theta, and that multiplied by cos square theta plus, I'm changing the order, right? I'm writing B square first, minus AB, that means minus cos theta into sine theta. And this whole divided by what? Divided by the denominator. Well, denominator is cos theta plus sin theta. So this is cos theta plus sin theta. And then I'm going to add, and now I'm going to simplify the other part. Well, here it is this. So if I do so, this is again, this time I'm going to apply this identity, which is a minus b, that is cos theta. I should write it from here. Now this is cos theta minus sin theta, right? This is cos theta minus sin theta, and that multiplied by cos square theta plus sin square theta. And this time we have positive 2 into cos theta into, not, it's not 2, right? It's cos theta into sin theta. Cos theta into sin theta. That whole divided by cos theta minus sin theta. Now what you can figure out here, that this cos theta plus cos theta plus sin theta get cancelled, and in the second part cos minus sin it is get cancelled. Further, you can notice that this is cos square plus sin square, which is 1. And same here, that is cos square plus sin square is what? 1. So we can write this in the first part, we are getting 1 minus, we have cos theta into sin theta, and this plus over here in the second here too, you can see that this is 1 here. Cos square plus sin square is what? 1. And for this, that is, we have cos theta into sin theta. So plus cos theta into sin theta. Now you can figure out once again that this cos theta sin theta and cos theta, positive and negative cos theta sin theta get cancelled. At the end we get 1 plus 1, which is equal to 2. And therefore we'll say this is our equal to the RHS. That's how we prove this question.